Assalamualaikum and hi everyone, my name is Shakira and these are my team members. I will start with the introduction for our video assignment Chemist 256. Coffee is a beverage brewed from roasted or unroasted coffee beans, a type of berry harvested from the coffea plant, known for its stimulating effect on humans. Coffee's primary active ingredient is caffeine, which coffea plants use to protect themselves against pests. While caffeine is toxic to most pests, it is generally not harmful to humans unless consumed in big amounts. The journey of coffee starts from its origin in Ethiopia, which in East Africa, to becoming popular worldwide, shows its importance in our daily lives. Coffee's energizing effects were first discovered by locals in Ethiopia who chew on coffee berries and experience increased energy levels. This led to experimentation with the berries, creating various products that can be made by coffee berries. Gravimetric analysis is a technique used to measure the amount of substance by weighing a solid. In this method, the substance is converted into a solid form by adding a chemical known as a precipitating agent. The resulting solid or precipitate must either have a known composition or be transformed into a compound with a known composition through heating. For a more detailed explanation, my team members will discuss it further with you about evaluation of caffeine content in coffee.
Now, let's move on to methodology. Gravimetric analysis for caffeine determination is not commonly used due to its complexity, but a theoretical methodology might involve in the following steps. The first step is sample preparation. Coffee sample will be dried by using an oven at temperature between 100 to 105 degrees Celsius until a constant weight is achieved to remove moisture. The dried coffee is then weighed accurately with a known amount. The next step is extraction of caffeine. After weighed, the coffee sample will be placed in a beaker and dissolved with hot water or an organic solvent. The mixture will be then transferred to a separatory funnel. In the separatory funnel, a solvent in which caffeine is more soluble will be added, for example, chloroform. Then the funnel will be shaken to allow caffeine to partition into the organic layer. This extraction process will be repeated multiple times to ensure maximum extraction of caffeine. The third step is isolation of caffeine. In this step, organic layers which containing caffeine will be collected from each extraction. After that, a rotary evaporator is used to evaporate the chloroform under reduced pressure to avoid thermal degradation of caffeine. This will leave behind crude caffeine.
The next step is purification. Dissolve the cured caffeine in a hot solvent and let it to cool slowly to recrystallize pure caffeine. This step needs to be repeated to improve the purity. Then, filter the recrystallized caffeine using vacuum filtrations and let it dry in desiccator. The fifth step is weighing the isolated caffeine. Before weighing, we need to ensure the isolated caffeine is completely dry. This is because any residual solvent will affect the weight measurement. Then, we can accurately weigh the dry caffeine using analytical balance. The last step is calculation. We can calculate the caffeine content by using the weight of the isolated caffeine and the initial weight of the coffee sample to calculate the percentage of caffeine.
the analysis result of calculation, the first one that we need to take note is we need to determine the mass of the caffeine precipitate after isolating and precipitating the caffeine from the coffee sample. This mass represents the amount of caffeine present in the sample. Next, we will be calculating the caffeine content using the following formula. For the mass of caffeine precipitate that we took is 0.5 grams and the mass of coffee sample is 10 grams. Lastly, the dilution factor are taken if the sample was diluted during the extraction process. Then it was considered as the dilution factor in the calculation. As there is no dilution factors, therefore the amount is 1. Then we considered the extraction efficiency is 80%. On the screen shown are the labels for each of the formula. Moreover, for the considered extraction efficiency, it is important to account for the efficiency of the extraction process. If not, all the caffeine was extracted from the coffee sample. We need to adjust the calculated caffeine content accordingly. Now for the calculation part. We took the sample preparation first, which is a 10 gram sample of ground coffee is extracted to isolate caffeine. After extraction and isolation, a caffeine precipitate weighing 0.5 gram is obtained through gravimetric analysis. These are the explanation of calculation part. As we took 80% as our extraction efficiency, then we adjust the calculation to be like this shown on the screen. Therefore, in this example, the calculated caffeine content in the coffee sample is 0.05 mg per gram. Adjusting for an extraction efficiency of 80%, the adjusted caffeine content is 0.0625 mg per gram. By following these steps and calculation, we could determine the caffeine content in coffee using gravimetric analysis. It is essential to accurately measure the mass of caffeine precipitate and consider factors like dilution and extraction efficiency to calculate the caffeine content accurately. Therefore, the adjusted caffeine content that we calculate are 0.0625 mg per gram when caffeine content divided by extraction efficiency.
To summarize all of our presentation, we evaluated the caffeine content in coffee using gravimetric analysis, a reliable method to measure the amount of a substance by weighing its solid form. Gravimetric analysis can successfully isolate caffeine from coffee beans, for example through liquid-liquid extraction and other methods mentioned during the theory and methodology. This precise method allows us to quantify the caffeine content in coffee effectively. Therefore, gravimetric analysis proved to be a strong and efficient technique for evaluating caffeine content in coffee. The results of this analysis are significant for both consumers and manufacturers. A detailed evaluation of caffeine content is important for accurate measurement in maintaining the desired effects and benefits of coffee consumption while reducing potential health risks associated with excessive coffee intake. These are our references. That's all from us. Thank you.